Okay, this is another one about innovation. There's this company which does this super interesting honeycomb paper structures. And they also do some kind of weird sand enclosure structures. And now they're developing with university, here they are, here are the two, with the university, this kind of interesting outer wall systems. Bernadette, what is it? Why is it innovative? And what are the challenges?
Why is it innovative? So this is innovative because it's purely made out of paper. So what we are researching on are different types of exterior wall systems that we can make solely out of paper. So to be honest, this one, of course, is out of paper, but we have a little bit of sand here and a lot of glue here. But this is the first round of prototypes. So we have two different exterior wall prototypes that we have here. Here are our more complicated version, and here are our simple version. And you already can see that those two prototypes have a different amount of layers. So here we have a lot of layers, and each layer has a different function because, as you know, exterior facade has to fulfill different functions to work as a facade. So here we have our sound insulation part. This is the white one. This is a product from Wolf Bavaria.
Yeah, this is here mainly for the reason of good sound insulation, and I show you afterwards the product and the inlay of the product, the inside, but in a few minutes.
Then moving forward, we have here a big block that is kind of a combination of load bearing and insulation. So here we have different cardboards that are oriented in different directions depending on the insulation value and the load bearing value. So as you probably know, a standing board can have a different load, can take a different load than a laying board. So this is why here we tweaked each layer to have the most impact, or the most out of each layer. And going inward, we also have some fire protection layers, which are different solid cardboard layers that are glued together.
And the other one?
Yeah, and here?
This looks a lot lighter.
Yeah, this one is a simple one. Even if you rock it a little bit, you can see this one is very heavy, this one is lighter. And here, because we are also in the university context, we want to understand, do we really have to optimize it to its maximum, or can we also do it more simple? Is it possible to have a paper wall out of simple layers? And this is why we do research.
And question we always have to ask, main problems. How do you see this as products? So when I think about paper, I would be worried about fire. I would be worried about water, humidity. How do you deal with that?
Yeah, I guess with the fire, that's why we have this solid cardboard here. It's made of 20 millimeter. It's more closer to wood actually than to paper in my eyes. So I guess with the fire issue, we will find a solution somehow. With the humidity and the water, this is part of our research. We will see, And the other thing with the thermal insulation, I don't think we get any problems there. We have a lot of air in between here, between the cardboard. And of course, we have a good solution for sound insulation with the Foamstar. So we also have the mass.
Foamstar, this is the magic word. What is Foamstar? What is Foamstar?
Foamstar, this is a really special kind of plate. And I will open it, and you will see this is the corrugated cardboard. And inside of this cardboard, it's sand, it's loose sand. It's really fine sand. And that's the reason for the good sound insulation, because you have a fine, heavy sand in the structure here. And we get a really, really good sound insulation for a panel, for 50 mil thickness.
He really likes it.
Yeah, I really like this one, yeah.
Hey, thank you.
You're welcome.